you that this is what I heard. They froze boiling water at room temperature. So Google this. Check this out, please. Froze boiling water, period. Yeah, that's it. Just Google that news. We'll see what comes up. I guess you could do the whole sentence too.
Boil water until it freezes
That's
solid.
June 18th. This is news as of yesterday. December. Freezing boiling water. They froze boiling water.
Boiling, freezing, and vacuum. Is it true that?
No, go to the top. Go to the top search bar, please. Boiling.
Boiling?
No, erase the whole thing and do water bridges at room temperature. This is some of the news and some of that water thread experiment.
Yeah, where water bridges, they'll hold each other together if they're having an electrical current go through them. Like you take two beacons and you send electrical current through both beacons of water.
Yeah,
Water, it starts to come out of the beacon and turn into a bridge. But I don't know if that's necessarily boiling the water rather than just sending electrical current.
this is different. This is different. This just came out yesterday. What did I share it in? I shared it on Facebook, Electric Futurism page, which Electric Futurism is going to be big. An author is picking it up with me, and he's a electric futurist artist and author. And he named his publishing company it now. This is probably going to be the easiest way to find it. Doot, 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 doot.
Watch piece metal sink in. Okay.
Farmer Field Coaster.
This is December 10th.
Oh, okay.
This is yesterday. This is yesterday. Prime iron,
Electric.
thrusters, magnetic field, and a toroidal field, and watch piece of metal.
Where would I share that on? Electric Universe Technology. Electric Universe Technology and Engineering.
Please. I don't.
It's a group. Yeah, right there.
Okay. Okay.
Well, that's not it.
Engineering, yeah.
Right there, buddy Doherty down here. Yep.
Oh, it is. It was the same group. Okay.
No, this is different.
This is gorgeous.
Yeah, Maxwell's electricity diagram. Vortex model of the ether. Yep.
Oh, geez. Yeah.
That's... Maxwell laid it out in place site. All of them did. They were all vortex scientists. And they all talked about the vortex in the ether as well. And Vladimir Ginsburg lays that out in the history very well in his books.
Now, why does it change from division to subtraction here? Why is it not constant tiling?
Well, water does this too, and water freezes in its fourth phase. And Gerald Pollack shows that water creates these tiling, and it becomes structured. Structured water is another word for it. And easy water is what it's called. That's an exclusion zone that you're looking at. Exclusion zones happen when there's a differential in charge and charge separation occurs in these exclusion zones. That's why it's called easy water. And they create these patterns. Every time water goes from freezing to boiling, it becomes structured water in between, and it goes from boiling or cloud to freezing. It goes through this fourth phase of water that structurizes it. Every time it goes through transitions, it structurizes. And this is part of the memory of water. And this is a big thing that um, uh, Jeremy Pfeiffer and what he's working on with Gerald Pollack. They all. I mean, I'm not sure if Gerald Pollack's part of it, but I met him in person, and he's a big proponent in showing this. And now it's very well to be known and true. But yeah, dude, easy water. Look into it, man. All of our bodies, it's like gelatinous. Our bodies, they say, is mostly composed of water. Z um, with a Z. Yeah, Gerald Pollack, structured water. You can look at photos too, and then it'll show probably some similar photos as to what we just looked at. Yeah, right there. And it stacks layers of hexagons against each other, and it becomes gelatinous. And we are structured water. You and I are structured water.
Is
Um,
this
and
water drinkable?
it's really weird. Like, it's strange. It occurs right between when water goes from water to freezing too. And you've probably tasted it and had it in a popsicle at one time or another. It's gelatinous and it's like layers and it's weird. It's not gelatin. Um, you can do easy water or structured water. Gerald Pollack. Yeah.
I've seen this future
Oh,
water bottle. This isn't they're using like sea kelp and stuff in the mix, so it's not
yeah. That's different. Structured water part one. Boom. You could go through that, just kind of scroll through, see some pictures.
fantastic.
Um, this is this this is the man here. I'm telling you what. This is where it begins, ends, and starts. And he's on the team, and he's moving forward rapidly. I mean, as far as the team, I mean the larger collective. He'll probably be out there at the Electric Universe Conference 2020 in Portland, Oregon, the first weekend of June, June 5th.
All
He's
right.
usually there. He's not there every time though.
Now we were looking for something on Facebook, and it was a having to do with not frustums, not the dodecagon. Do you remember what it was?
Uh,
You were all hype about it.
oh, let's see about water and about us being able to freeze water. Let
Freeze water, yes.
we can
Yep.
freeze. We were able to boil water. Let me look at my personal page here. I'm seeing if I put it on my personal page. If I saw it, I would want to share it, and I'm so upset if I didn't. It could be, let's see, would I term that electric universe biology, geology? Do 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 do. Yesterday was the 11th. It was a big day. I had done so much. So, yep, there's the 10th. Let's see. Let me look at my groups and try to find this because tracking this down is going to be really well worth it.
Good, you have posted it on your main, your on Buddy James.
Electric universe geometry, I might have posted it. I'm looking. I looked at my page, buddy James, and it's not on there.
Okay. I'm looking at electric UG. What the hell? What?
Yeah,
See?
it's snow that slid down.
What? This world does the strangest things. Yeah, the Roman dodecahedron, you were right, yeah. Okay. And, oh, yes, this world does the strangest things.
Freezing boiling water.
You found it.
According to Wired, the leading explanation for this strange phenomenon is fairly straightforward. Hot water evaporates more than cold water. As boiling water cools down, a small amount of its mass is turning to steam and floating away. Hot water freezes faster than colder water simply because less of it has to turn into ice.
You do a lot of sharing. While you're
Yeah.
eating.
Yeah, that's why I have some numbers, moving some things around. I got a lot of people's attention for the Brighton Buddy show and a lot of people's attention for bubble sculpting.
Fantastic.
Yeah, those are going really well for likes per ratio of views.
Oh yeah. How's bubble sculpting going?
Couldn't be going better. I mean,
a whole bunch of more solids.
I'm gonna make a bicone today and show bicones moving into bicones where the phase conjugation happens.
Oh, can I show you something real quick? Go to where the screen share is. The Skype.
Screen share?
Like I'm sharing my screen right now. If you want to take
you
a
want
look.
to see my screen? I can see yours.
Okay. Yeah, I was gonna show you something.
Okay.
This is how Archimedes equated pi, and he took the kind of like a. Well, I could go ahead and read this exactly, but you know he's taking this blue. How do I say this? The circle around the blue hexagon is the circumradius. So it circumscribes the hexagon. And the circle inside this other hexagon is the inner radius. The circle is the inner radius.
Okay.
And this is how Archimedes equated pi. He kept doing this with higher and higher number of polygons. But this is exactly what you're doing. You're saying, oh yeah, I can apply this to any shape of the same thing. Can you see what I'm talking about?
Yeah. Oh, 100%.
Okay, so yeah, working with an Epiragon polygon is the way to estimate exactly what pi is. It has to be an Epiragon.
Which is like as many sides as possible, which is almost a circle.
Infinite, yeah. Infinite sides on a polygon, yeah.
Okay.
And that would be pi. For the inner hexagon and outer hexagon, when you approximate them together, yeah. Anyhow, I was just throwing that out there as an idea for the Dowdy set sort of thing you got going on. Because, I mean, you can use polygons to explain it, but when you're basing the whole set off of the circumradius and inner radius, you're basing it on the actual circles rather than the polygons. This set's about the circles. It's about sphere packing it and circle tiling, not the polygons anymore.
Right, but the polygons give you the precise definition and value of the circumradius per each one's different circumradius for moving inward nested. The nesting and the moving inward, I think, is the quasi crystals.
Yeah, okay.
So the nesting and the moving inward is creating it into a quasi crystal, and that tessellate, and then you can tessellate it outward from there and turn it into projective spherical standing wave structures. Each
I
one
see
has a different
exactly
sphere.
what you're saying. Yeah, I see exactly what you're saying. Now,
Yeah.
if I can say this with these two images here, and you can see it in your own diagrams, and you might want to, like, or I could probably diagram a mathematical model for this. But you can see if you take this, like this side length right here, the blue side length, and this one, and if you boost up the number of sides in the polygon, then the circumradius and the inner radius, or how do I say this?
They gradually move ever closer towards pi.
Yeah, and towards
They
one another.
radiate towards pi.
Yeah.
Right?
And, towards one another as well. See this corner right here? We'll get closer and closer to this point in here.
Yeah.
To the actual circle, it will get closer and closer. And this polygon here, this edge here will get closer and closer to this point.
Okay. So I could do the Doherty set with what's the inscribed name? Not the circumscribed, but the
inner radius. Inner radius. Okay, so you think radius of a circle. But inner radius is used for polygons. So if you have a polygon like a hexagon, the inner radius is the center of the polygon to the side length, the middle of the side length.
Shouldn't it be called that one's a circumsphere. This one is
circumsphere. What?
Is that what you called it?
No, circumradius.
Circumradius. But if you turn it into a 3D, then it's a circumsphere, right? Or
No, it'd still be circumradius.
Okay.
Because a radii, you know what a radius is? It's half of a circle.
Yeah.
And a circle, you can look at a sphere and bisect it into second-dimensional circles anywhere. So it's still a radius, a radii. So like the center point of this, where the one is, kind of like the center of the circle, or the center of the hexagon. You take that point out to where the middle of the side length is of the hexagon, and that's called the circumradius.
Okay.
Pardon me, no. Pardon me, inner radius.
Okay, yep.
Inside the polygon.
Yeah.
You're going center to corner, center to apex is circumradius. Center to center side length is inner radius, yeah. And I could look into an equation for this, which is something different than the equation for see, I can write the equation, a basic equation for the infinite expansion of this. Get out of here. Oh shoot. Don't make me go through this nonsense. What the hell? Okay, well, yeah, for this piece right here, let's say that this keeps decreasing by, is that, yeah, 0.5. Yeah, that should work. And then I can go ahead and throw this in. Oh, that's this. No, it has to be 1.41.
It's not the same size to begin, though.
Whoa, wait, why is that larger? That's
you gotta copy and paste it again.
Oh, it's because they're on different like this one's closer.
Oh, I get it. That's cool.
1.4. No, yeah, it's 1.4142 is the square root of 2, and I can do that again. 1.4142, and that should be close enough. And I can go ahead and come on. Yeah, and you can keep expanding it by the square root of 2 of these squares.
Mm-hmm.
So, yeah, I might as well just go ahead and make this.
And this is how sound is created in tunnels and separated into minimal energy filaments that create the frequencies that necessitate creature stacking. I'm going to keep using this word creature stacking because that's what we are. We use the word solar cycle, but solar cycle, another word for it is creature stacking. And we need to keep coming up with synonyms for the solar cycle. The more synonyms we can come up with for solar cycle, the more we can get in involving the geometry, the more we can get into the actual tangible truth about what this is. You follow?
I'm not entirely sure what you mean by how a solar cycle relates to all this. I haven't seen the diagrams of its relations yet.
Well, if you type in the inverse square law,
Inverse square law.
go
Yeah.
ahead. That will
I
tell you
know
all
what
you
you're
that
talking
will tell you all you need to know, and then from there it's history.
Are you talking about how photons reach the Earth,
Everything
sun?
does this. Everything.
And it's
It's the law. It's the
universe.
law
It's
of
also
electromagnetism, gravity, um, light, sound, photons, anything. That's the Doherty set right there. That's how it moves out. And all physical laws, if you read it, dude, it's fucking everything. So mapping out this geometry, which is the geometry of the square within the square, then you get all of how signal propagations, everything. Waveguide, you get the condensate of how waves actually where geometry comes from, the origins of geometry, and what number is.
okay.
You follow now? You got to be able to wrap your head all the way around the fact that this is all coming from the sun on a constant. And from every single atom and from every single electron. If
Great.
there atoms and electrons exist, you know what I mean? Every packet has this geometry coming from it. And that's the Doherty set. And that's what we're working with. And that's why it's so important. And it mirrors the shapes of all the creatures. The creatures literally come out of it because of the sound and the harmonics creates the skeleton of the exoskeletal creatures, the skeleton of the leaf patterns, the skeleton of the sunflower, the skeleton, everything. You know, it's the same pattern repeating itself over and over. The pattern of this is the Doherty set. So the more you look into what this is, then you can start to understand the geometry we're working with.
Okay. I'll have to give this an in-depth read and find some other articles on it as well.
Oh yeah, it's backed up constantly from beginning to end. I'm almost blown away at how simple it is and how the lack of people talking about it, and how it can how I've quantified it into a system. This is just one of them. Now, if you look up other laws, the laws of all of the laws can, should, and will be described using a simple set of geometry. The four fundamental forces all exist as one set, and there are four different parts of that one set.
Okay.
Which are the four fundamental laws of physics are the electroweak, the electrostrong, electromagnetism, and gravity. That's the four. And from there, everything's created out of those. So there's a geometry of the electroweak and there's a geometry of the electrostrong too, on a quantifiable level. And sure, we might be able to prognosticate what it is. And this is some of the stuff that I'm telling you about. The Doherty set is so predictive in its nature that you can make predictions and and show real working models that work in day-to-day examples. There's so many so many predictions you can make in the future predictions, you know, they're laid out all around us, and you can use geometry to your advantage, the predictive power of it, shape power of it. Everything is a certain shape, the shape of your ribs, so your body can move along its spine. I mean, butterfly wings of your ribs and your lungs, butterfly wings of electrical scarification, butterfly wing scarification. If you tape out ribs, yeah. Whoa, man. I wasn't talking about that kind of scarification. I forgot about that body stuff. Can you type in Andy Hall after that? This is the guy that you really need to study. He's one of my favorite people ever in the world. Him and um, uh, Bruce Laybourne. He's awesome too. No, don't type Bruce in yet. But if you look at, let's see.
Yeah, I know how to do it.
Take out butterfly wings. Oh yeah, you can put Andy Hall in like that. Nope. Okay, just type in Andy Hall scarification. Yeah. Okay. All right. Andy Hall Electric Universe.
That'll bring it up. Damn.
I know, right? It's hard to get him. How does electricity carve a planet's surface? The arc blasted Earth, the electric Earth, dude, gorgeous. Goes into multiple vortices. Oh, that
Look.
one is a must. That cloud, the thermal pile in the cloud. Oh, that's a must, dude, for anybody, everyone who wants to learn about what the electric universe view and my understanding proof of how a thunderhead works, which is a cumulonimbus.
Cats.
But it's really cool. I love weather. I love a lot of things.
All right, here we are.
This dude, man, he got heat exhaustion the first night we were there, and I met him, and he was sitting next to me, and he got all dizzy. And Neil's like, dude, maybe you should walk him to his room. So I was walking him to his room. I literally just grabbed onto him, and he fell like a hunk of, like a sack of potatoes, smashed his head on the freaking table. And the next day was his presentation, and he had a black eye, but he rocked it. He rocked it hard. He's great. Oh, that's the picture from, he's got the glasses on from the black eye. But yeah, this stuff, so good. And his videos on how Jupiter, the multi-cyclonic action of vortices and multiple vortices, it's like the vortexture, man. Whew, so good. Like it literally is the vortexture. That's how the planets are sculpted. He says the red spot is huge columns of this storm that's just these large vortexes, multiple ring vortexes, and it's just wonderful listening to him explain it and how it's scarring the earth underneath it and creating he's relating it to places on our planet that have the same type of latitude where there are similar unknown huge like excavated parts of the ground, and this is from these storms. They excavate mountains and they move huge amounts of material from one place to another on the planet.
All of this information, I'm going to look through this when I wake up, and I'll get back with you.
Awesome. I love what you're doing, man. Keep it up.
I love what you're doing, dude.
All right. Talk with you soon. Have a good night. Get some good sleep. Thank you for joining us on mini episode 4, an episode in between episodes. Next week it's Helix. Brighton Buddy Show is a Love is Watching production. Love is Watching, thank you for doing that. A lot of exciting guests lined up for 2020 and coming up here for the end of 2019. Our next episode is the Helix, or we might have a 3-part episode. Executive producers for the Brighton Buddy Show are Brighton Cotter and Buddy James.